Hello everyone, I'm Vinayak Koppad. So in this video, I'm going to show you the isometric projection of combination of two solids, that is frustum of hexagonal pyramid and a sphere. So let's begin with the problem. A sphere of diameter 30 rests on the frustum of hexagonal pyramid of base 30 mm and top face 18 mm side and height 50 mm such that their axes coincide. Draw the isometric projection of combination of the solids. And for this, so we need an orthographic projection. And here is the orthographic projection of the combination of solids what they have given. So when you look at the frustum of hexagonal pyramid, this is how it looks in the top view, and the sphere as usual it looks like a sphere, and this is a front view of that one, right? So first we need to put this 30 base side hexagon within the box, and we have to name it as a 1 2 3 4, and for the corners A to F, and we need to measure these dimensions also. Okay, next, so first we shall draw this rhombus, that is 1 2 3 4. So first 1 to 2 it is 60 is there, and it is 1 to 4 or 2 to 3, so which is coming out as a 51.96. yes, take a line command. So first it is 60 30, then it is 51.96 at an angle of 150. Next again it is 60 minus 150 and remaining as usual 51 point something. So this is the rhombus what we have drawn. So that is 1 2 3 4. So 1 2 3 4, right? So now on this one, so on this, so first we'll make this as a thin lines. Okay, so now look at the box here. So on 1 to 2, okay, so let's begin with the A here. So on 1 to 4 you are getting a corner. So what is the dimension of that one? So you can measure it from 1 to A. 1 to A is 25.981, 25.981 it is. So take a line command, 25.981, so which is same as 2 to that line also, 25.981. just cross check whether it is right or wrong. Yes, 25.981. so now we have drawn A and D. Similarly, so measure what is the distance from 1 to B, and which is same as 2 to C, 3 to E and 4 to F. So go here. So now again draw the 15 mm lines on these lines. Again from 4 to it is 15 mm. Again 15 mm. Yes. So now we have drawn all the corners here. Only thing is we need to connect it. So this is A, B, C, D, E, F and F to A. So once you have drawn these lines, so you can trim out the lines whatever you have drawn. You can delete it. Now you can join the midpoint of these two lines, so that in order to get the center of that one, so we need to connect to the midpoint here. Yes, so we got the midpoint of the hexagon here. So this is the bottom face of the hexagonal pyramid. So now what is the height given in the problem? So height as a 50 mm. So draw a 50 mm line here. So 50 and vertical line 90. Right. So now, so in the computer you are having an option called as a scale command. So now select this bottom face of the hexagon. Otherwise you select the necessary lines, that is hexa 6 lines together with these midpoint lines you want. So this you have to go for a scale here. Go for a scale, switch on the copy, and here the top dimension is 18 divided by bottom dimension is 30. So you will get a top face automatically here. So this top face you just block it, and you can connect to the midpoint of that one, midpoint of the axis here. Okay, this is advantage what you are having in the computer. Now you can join the corresponding corners. Yes. And again, when you look at from the front, so the behind lines whatever you have drawn that are not visible to you, so select all those lines and just make it thinner lines, right? So whatever you are seeing, just make it only those lines as a thick lines here. Next, on this frustum of hexagonal pyramid, you are having a sphere. So before that, before drawing the sphere, first we need to draw the radius of that. So what is the dimension they have given? It is a 30 mm. Okay, so 30 mm. So draw 15 mm, that is a radius of the sphere. Now select all these lines, go for the scale. So now, so you convert this to 0.816. So because in isometric projection, one second, so select this line, go for the scale command, switch off the copy option, so 0.816. now all the lines are converted to the isometric lens here. So here in the isometric projection, the sphere are actually drawn to the actual dimension. That's for, so before that step whatever you have done, so convert all those lines to isometric. Afterwards you draw the sphere here, so the of 30 mm diameter. And here also inside the sphere whatever the lines that are coming, so those are actually not visible to you. You can remove these, all these lines, and this will be the axis of the sphere. And these two lines, again this line and this, only this portion, that means again we need to use a split here. So split this line and at this point, yes, only that portion we have to make it as a thin lines. Yes, remaining lines actually you are having a dark one. So this is the complete solution for the given problem. Thank you.